great pleasure to be here on this incredibly beautiful campus. I am so jealous. This place is just beautiful. The architecture, the trees, it's just an amazing place. And I love the emphasis on experiential learning. That's something I feel very strongly about. So I spoke to the Marine Science Institute students this morning talking about the importance of exploration, and I don't seem to have a pointer anymore. Oh, here it is. Got hidden. So I want to make a case to you this afternoon that we need explorers now more than any time in human history. We are by nature explorers. That's who we are as human beings. And when we were first exploring our world, we used to create maps such as this one, which would have monsters at the edge of the map, or here be dragons, or here be monsters, they would write. And it was the unknown world. And in some ways, it was meant to warn people off, but it never had that effect. It seemed to draw people on. Because we are all essentially explorers. We are born as strangers in a strange land. And we learn about our world by exploring it. So the first time you crawled away from the safety of your mother's arms to look around what was that corner, you were being an explorer. You were trying to figure out your world. And it is a completely essential part of being human. Exploring and sharing knowledge about how the world works is foundational to our survival. We had to figure out which animals were dangerous, what food was safe to eat, how to start fire, how to create tools, and we would share that knowledge. And it fostered our survival on this planet. In modern times, our drive to explore has led to extraordinary discoveries, ingenious innovations, and fantastic achievements. So how is it possible that we have explored so little of our own planet? You sometimes see infographics like this, which was at the National Aquarium. It says it's easy to ignore what we cannot see. We've mapped 100% of the moon, 100% of Mars, and 5% of Earth's ocean. That number is a little questionable depending on what you mean by mapped. But if you're talking about multi-beam sonar, which is one of the higher resolution mapping tools we have, then actually now it's more like 10 to 20% of the ocean that we've mapped. But that's at a resolution of 100 meters, basically about the size of a football field. Anything smaller than a football field, you're not going to detect. And you sure as heck aren't going to be detecting life. You're just going to be detecting bottom topography. If you want to talk about really exploring, where you enter the ocean and see what's there, then we have explored less than 0.05% of the ocean floor. Now, to put that in perspective, that would be the equivalent of exploring 3 city blocks out of the entire island of Manhattan. So why do we need to be exploring the ocean, and why now? Why is this most particularly important right now? Well, unfortunately, we are poised on the brink of massive destruction of our oceans. And this is part of the machinery for life. And to be honest, folks, we don't really understand how it all works. We're just barreling along on this rock that we call a planet. And it's the only rock in the universe at this point in time that we know of that can sustain life. And we don't really know how it's doing it, but we're messing with it. So I would be remiss if I did not, as a scientist, share the following information, but I promise it will only hurt for a short time. So here we go. First of all, we're heating up the oceans. We're heating up the planet, but the ocean has been taking the brunt of it. It's been buffering us against our heating from the burning of fossil fuels. And that's causing problems with thermohaline circulation patterns, these great rivers in the sea like the Gulf Stream that carry heat around the planet. And if we disrupt that, we're disrupting what has been a stable climate for eons. And it has made, the thermohaline circulation pattern is what made agriculture possible, because we ended up with a stable climate that was predictable. And without that, you're going to have more floods, more famines, more droughts, wildfires, and we're already seeing it, but it's going to get worse. We also have the real fear of melting the permafrost in the ocean and on land and causing a positive feedback loop where as the permafrost melts, it's releasing organic matter to microbes that are going to break it down and release more CO2 in the air, and it just becomes a permafrost bomb. We've been putting out CO2, which is that red line you see there from 1955 until past now, huge amounts of CO2. And they've been being dissolved in the ocean. That's the green wiggly line. And when carbon dioxide dissolves in the ocean, it turns to carbonic acid, which makes the oceans more and more acidic. And we're already seeing the effects of that on calcifiers, like sea butterflies and shellfish and coral can no longer create the architecture of their homes. Plastic pollution, we all hear quite a bit about that. There's also nutrient and chemical pollution that we're pumping into the water in all kinds of different ways. We have dead zones, the one at the base of the Mississippi, now the size of Connecticut, and there's more than 400 of them around the world, places in the ocean that cannot sustain life any longer. We are destroying our precious nurseries of the ocean, the estuaries. It's so nice to see a lot of the St. John's still has healthy estuary, and it's essential that it be maintained because that is a huge, huge impact on the ocean as a whole, is that these estuaries have to be preserved to sustain a lot of the ocean life. Overfishing, bottom trawling, where we drag these nets across the bottom and cause the bottom fish and shrimp to jump up into the net, but in so doing take a Garden of Eden like you see on the left and turn it into a moonscape like you see on the right, something that won't sustain life for hundreds of years. We've got deeper and deeper oil rigs out there that are all poised to do what the Deepwater Horizon did in 2010. And then we're on the brink of what's being called the new global gold rush, with the need for precious metals that we need in our computers and our cell phones and our batteries are now going to be dredged up from the sea floor with tremendous damage that's going to go unseen because it's out of sight and out of mind for most people. All of this has the exact same cause, people. There's too many people on the planet, and it's exponential growth. And all of these hockey stick curves that we see with water use and species extinction and more motor vehicles and fisheries exploited and ozone depletion, all of these connect to too many people on the planet. So we know all this, and yet we're not acting in the way that we should. And the problem is probably one that's partly psychological, and there's two components to that psychology. The first is what's called the boiling frog syndrome. And it's the concept that if you drop a frog into boiling water, it'll have the sense to jump out. But if you put it in warm water and then heat it slowly, it'll be stewed before it jumps out. Now, personally, I'd like to think frogs are smarter than that, and I really think humans are. But the problem is that it's so easy to just put things off. It's not an immediate threat. And so, well, you know, got to pay the mortgage, don't really have time to deal with this, worry about it tomorrow. Besides, I don't know what to do anyway. And then the other problem is one that's been expressed as Martin Luther King did not mobilize the civil rights movement by preaching, "I have a nightmare." But that's what the environmental community keeps doing, and then we wonder why nobody wants to listen to us. After a while, you just want to plug your ears. You don't want to hear it anymore. Plug your ears and close your eyes and pretend it's going to go away. Well, I think part of the problem is we need a different outlook, one that focuses on our strengths rather than our weaknesses. And our strength is exploration. That is what we are really, really good at. It drives us. And yet, I have seen so many young people that are completely unaware that we have explored so little of our own planet. They think it's all been done. In fact, that's what NASA has been using as one of its reasons for space exploration, is we've explored the planet, our planet, now we have to move on. Well, we haven't even come close. All of the exploration that's ever been done on this planet could be outdone by what needs to be done in the ocean. So when we talk about how we explore and why we explore, it's important to understand how we solve problems. And there's two ways you can go at problem solving. One is you can build a ladder to a solution, and the other is you can build a pyramid. And we can occasionally build ladders. I mean, that's what we did for the moonshot, and everybody holds that up as a great accomplishment. But it was one point in space, and then it's all kind of tumbled down because they didn't have a further on plan, for one thing. And if you build a ladder to a point in space and you make a mistake along the way, the whole thing comes crumbling down. Exploration forms the base of the pyramid. And sometimes solutions come from very unexpected places. There's a new book I just read recently called Range: Why Generalists Triumph in a Specialized World by David Epstein. I recommend it highly. It's really good reading, and it talks about how many major discoveries and solutions to problems have come from left field. So returning to exploration, I mentioned those 3 city blocks, but that's just actually 3 city blocks on the first floor. The average depth of the ocean is 2.3 miles. That's almost 10 Empire State Buildings tall. So it's like we've only explored the first floor of those 3 city blocks out of the entire island of Manhattan. And the way we've been exploring is very primitive. Most of what we know about lives in the ocean. We know about because we've dragged nets behind ships. And I defy you to name any other branch of science that still is so dependent on hundreds of year-old technology. But that is the primary way we know about life in the ocean. We bring it up into our world where we're comfortable, but it's not. So you're looking at dead animals, and you're looking at them as an integrated whole. So you have no idea if those shrimp were all hanging out together on the street corner and the fish were in some other place. They're all just in this big soup. And for a long time, we thought the ocean was just big soup. But the more we look at it, we realize that there are very discrete layers and different patches, and it tells us a lot about the ecology of the system. The other way we've explored the ocean is we enter it with either submersibles or remote operated vehicles. But the problem with these platforms is they have bright lights and noisy thrusters. And this always drove me crazy. I mean, I've done a lot of my work in submersibles, and I love submersibles. But I would sit there in the sub with the lights on and just wonder how many animals are there just outside the range of my lights that can see me, but I can't see them, because we're scaring them away. Most of these animals don't have any protective measures for their eyes the way we do with our eyelids and our irises, and they're just, everything's about gathering as many photons as possible, so the only thing they can do to protect themselves from those incredible bright lights is run away. Okay, as an example of scaring things away, I would like to bring up the example of the giant squid. This creature was, for a long time, a myth. It couldn't be believed. It was the usual sailors' stories about the one that got away. But they would come back and tell tales of this creature so large it could be mistaken for an island when it was floating at the surface, and so monstrous it could pull ships and men to their deaths. And the Norwegians called it the Kraken. And it remained in mythology until 1861, when a French warship working off the Canary Islands came upon one floating at the surface, fired a few cannon at it to make sure it was really dead, and then threw a rope around it and tried to bring it on deck, but it was so heavy that the line cut right through the body, and they just brought back the tail section, and the head fell away. But it was enough to convince the French Academy of Sciences that it was the real deal. And so it got written up, and Jules Verne, who happened to be writing 20,000 Leagues Under the Sea at the time, saw that write-up and included a giant squid in his tale, including a terrifying battle, supposedly, and helped add to the mythology of the beast for a long time. So it was considered the holy grail of natural history cinematography to actually get imagery of a giant squid in its natural habitat. We had plenty of pictures of them because they happen to float when they die, and they would drift up on beaches, and there were samples that had been studied for years, but nobody had ever seen one alive in its natural habitat. And there was a series of expeditions that were put together by people that sort of became almost giant squid hunters, and they didn't succeed. These would usually be written up with documentaries. At the end of the documentary, you'd have the chief scientist at the bow of the ship looking at the sunset, a little tear rolling down his cheek, as the narrator would talk about the fact that exploration is hard. Will somebody ever find the giant squid? And that was how it would end. Well, I'm not a giant squid hunter, never was, and never intended to be. I got into this because of my interest in bioluminescence. So this is about coming at something from a different angle, completely different angle. So I was doing my PhD on a bioluminescent dinoflagellate, and my major professor, who was brilliant at getting funding, got funding for this new instrument called an optical multi-channel analyzer that was the most sensitive spectrometer ever developed. And he got this instrument. It was just sitting in the lab and nobody was using it, and so I couldn't keep my hands off it and started playing with it, and finally figured out, how to get it working and calibrated. And then he comes to me and he says, well, now that you got this thing working, we need to send you to sea to measure all these animals in the deep ocean that can make light that nobody's ever been able to measure before. And suddenly I was the thing I'd always wanted to be in the first place, which was a seagoing marine biologist, and I was thrilled. And then because of that experience and more like it, I ended up being included with a group of scientists that were testing this device, which is called WASP, because somebody thought it looked like the insect. That's not an acronym for anything. It was used by the offshore oil industry for diving on oil rigs down to 2,000 feet. And I was with a group of scientists that were testing it to see if it could be used for midwater exploration. And I tell people that diving in WASP completely changed my understanding of the nature of life in the ocean. Also changed my understanding of the expression colder than a witch's tit. It's a metal suit, and the deep sea is very, very cold. And you'll note the wool cap. I think it was Jerry Seinfeld that said, what do you lose, 80 or 90% of your body heat through your head, which makes it sound like you could ski naked if you just had the right hat. The hat helped, but it didn't solve the problem. And I would come up from dives with my lips blue and my teeth chattering. And there was this old oil rig diver named Charlie that was in charge of the dives, and he finally took pity on me, and he pulled me aside, and he put his arm around my shoulder, and he said, look, I'll let you in a little secret, but you gotta promise not to tell any of these other guys. I said, sure, Charlie, what is it? Pantyhose. Which is sort of like silk underwear, and I did use pantyhose, but I was never sure which kept me warmer, the pantyhose or my vision of Charlie wearing pantyhose. So my first dive was in the Santa Barbara Channel, and I went down to the unimaginable depth at that time of 880 feet, and I turned out the lights. And I turned out the lights because I knew I would see bioluminescence, but I was just completely unprepared for how much I saw. It was incredible. It was like Van Gogh's Starry Night. And I knew enough about bioluminescence at this point in my career to know how much energy it took for animals to produce light. And I knew enough about biology to know animals don't waste energy. I felt like this has to be one of the most important processes in the ocean. I couldn't understand why more people weren't studying it. Now, as it turned out, one of the reasons most people weren't studying it is there weren't instruments that you could use to measure it. So I spent a lot of my career developing those instruments. Now, usually if people are familiar with bioluminescence, it's these guys, fireflies, and there's a few other land animals that can make light. There's earthworms and millipedes, and even some fungi, but in general it's rare on land, and nothing could be further from the truth in the ocean. In the open ocean environment, most of the animals make light. 70%, 80%, there's some places it's up to 90%, depends on where you are. But they use it to help them find food, to attract mates, and defend against predators. So one example of defending against predators is this common deep sea jellyfish, Atola, which produces a magnificent pinwheel of light that's called a burglar alarm. And it's called a burglar alarm because the theory goes like this. The jellyfish is swimming along, minding its own business in the dark, and something munches on it. Well, now the jellyfish lights up, and in so doing lights up the predator, which then attracts its predator. So it's the same as the burglar alarm on your car. The blaring horn and flashing lights is meant to attract the attention of the police and scare the burglar away or get the burglar caught. So I wanted to test this theory. So I developed what we called the electronic jellyfish, and it was just a ring of blue LEDs on a circuit board and encased in epoxy, and actually you can see what a shoestring operation it was at the time because you can still see the word Ziploc in the mold that we used to cast the epoxy. And I needed some way then to be able to observe how animals responded to this, but I didn't want to do it, obviously, with white light. That's not going to work. So I developed this camera system that used red light that was invisible to these deep sea animals. And it was a battery-powered system that could be carried by a remote-operated vehicle or a submersible and put on the bottom of the ocean. I experimented with different types of illumination systems until I finally got one that was able to work without scaring the animals away. And what I discovered was that that particular display was in fact very attractive to large predators. That is a Humboldt squid, and you can see, we would see this again and again and again. They loved this display. This one comes in, and you can see how miffed he is that there's not actually food attached to the jelly because he inks. And this next one is what I call the Einstein of squid, because he comes in and immediately realizes something's not right. And he's persistent, though. There's got to be food there somewhere. He just knows it. And then he goes away, and he thinks about it for a while, and he thinks, well, maybe if I come in from a different angle? Nope. So I showed this video at actually the Mission Blue that Quint was talking about on the Galapagos Islands. It was the first TED ever done at sea. I had no idea what TED was, but I wasn't going to turn down going to the Galapagos. So I went and gave a TED talk at sea, and there was a giant squid hunter in the audience who got pretty damn excited when he saw that video, and he said, would that work for giant squid? And I said, yeah, I think it might. And so he ended up getting me invited on this television-funded expedition to Japan off the Ogasawara Islands, which are just south of Japan. And it was a huge expedition funded mostly by the Japan Broadcasting Corporation, NHK, with some money from the Discovery Channel. And it was an opportunity for me to spend 6 weeks at sea testing a new version of the Eye in the Sea camera system that I'd developed. And this one was different in that I no longer needed a submersible or a remote-operated vehicle to deploy it. It's the same principle, though. It was an intensified camera with red light illuminators. There's an electronic jellyfish, a slightly different version of it. But the whole thing is on this platform that could be thrown off the back of the ship, and then there was a half-mile of line attached to the camera system up to a float at the surface that had a satellite beacon on it so that I could track it. So we just throw it off the back of the ship, and then we go off and do other operations, and the next day come and pick it up, track it by the beacon, figure out where it was, snag it, bring it on board, download all the video, and see what we had caught. Now, if you really want to see what we got, you're going to have to go online because the video is not playing. And Murphy is absolutely determined that this video does not work for you today because I tried to show it at Marine Science this morning, and it wouldn't run off my thumb drive, so I was going to use my laptop, which I know it runs off, and my laptop stopped working. So you're not meant to see it this way, I'm sorry. But one of the cool this just shows me deploying the camera system, but one of the cool things was because they were filming all the time, they got moments that you don't usually get to share with the public. And they had cameras running, so when my colleague and I here were reviewing video, they catch the very moment that we see the first giant squid ever filmed, and us just screaming our heads off. I mean, scientists losing their minds. You know, people came from all over the ship to watch, and it was absolutely phenomenal. If you really want to see this, there's a TED Talk that says how we found the giant squid, and there's also the Discovery Channel program that they produced, which had the really unfortunate name, Giant Squid, the Monster is Real. Actually, that's not the title it had, because we complained so bitterly that, first of all, of course it's real. We've been studying them forever. And secondly, we don't think it's a monster. And I swear this is true. In response to our complaints, they changed the title from Giant Squid, the Monster is Real, to Monster Squid, the Giant is Real. And their response was that monster could refer to its morals, and I mean, refer to its size instead of its morals. Anyway, I was not really happy with this documentary when I saw it, because it was very people-oriented instead of natural history-oriented. I saw the Japanese version that NHK produced, and it was much more like the old BBC-type productions, and you had really, I mean, we had incredible footage of giant squid, and they just show it in these really short clips because they've got the American public so cued in now to short attention span that anything more than 10 seconds, you know, the attention span of a goldfish is out of the question, apparently. So I wasn't happy about it, but I had to rethink it a little bit given the feedback I've gotten from people, and a lot of people liked this because it was more people-oriented, and it showed the interaction of the scientists, and they tried to make a competition out of it between the three scientists that were on board, which we were all absolutely opposed to and appalled by, but they, of course, did it anyway. And I didn't mind so much since I was the one that won, but it's still, you know, was not how science is normally done. But anyway, you can see scientists losing their minds there. Then this summer that was in 2012. And this summer, 2019, was the first time I got to use the camera again, and this time in our own backyard. And this was about 100 miles southeast of New Orleans, a place near DeSoto Canyon. And we were deploying the camera again with a half-mile of line out. And this is the salty crew I was out with, some of my favorite people to go to sea with. And Nate Robinson was my colleague that was working most with me on this. And so what we would do is we'd throw the camera out one day, pick it up the next day. That night we'd download all the video, and then the following day he and I would trade off running through the video to see what was there. And so since this wasn't a television-funded expedition, I can't share the moment with you except verbally, but I was in the mess, he was in the lab, and he walked into the mess, and the expression on his face was just like his eyes were popping out of his head. And I jumped up and ran into the lab, and you know, he showed me what he was seeing on the video, and that at least I can share with you. So initially what you're going to see is what looks like an arm, but it's actually arms all held together at the side of the left-hand side of the screen there. And you have to forgive the scientist in me, but what's thrilling about this is you can tell that it's hunting the jellyfish, because the jellyfish was kind of going up and down, and it was going up and down, and it was just tracking along with it. And then we had several sequences like that, and then we got this. You're allowed to gasp. We all gasped. So that is a juvenile giant squid. It's as tall as a 2-story building. And a full-grown giant squid can be as tall as a 4-story building. And so, you know, we're screaming. Everybody comes running from all over the ship. We're all pulling out taxonomy keys to make sure it really is Architeuthis dux, because as a friend of mine describes it, scientists are basically like a car where you've got both feet full on the accelerator and the brake, because you know, we're really jazzed about what we do, but we hold down the brake all the time because it's so easy to make a mistake and you don't want to blow it. And so, you know, we're trying to make sure that this is really the real deal. And suddenly there's this enormous bang, and the ship had been hit by lightning. In all my years of going to sea, I've never had that happen. We run out onto the back deck, and there's this big plume of brown and yellow smoke, and there's bits of antenna lying all over the deck, and we all look at each other at the same moment and think, oh my God, the computer, we hadn't backed up the video yet. And we go running back in, and it was okay. Some of the other computers did get zapped. And we're still standing there kind of in shock, and the captain comes down and tells us that there's a water spout forming off of the port bow. So it felt like Poseidon was trying to hold his secrets. And we were in the middle of a squall, so we couldn't get the internet, but finally, we got the internet up, and we sent the video to Smithsonian, and the world expert on giant squid confirmed it was a giant squid, and we were allowed to take our foot off the brake, and you saw scientists losing their minds again. So while we were out there, we did an interview from the bridge of the ship with the New York Times. And actually, you know, the New York Times was kind of funny about this, because the Brooke Jarvis, who did the interview, later told us that, you know, she didn't realize at the time what a big deal this was, that she did it, because she said afterwards, I'll do any time, any place. It got more hits than anything she's ever done. And then it just went viral everywhere, to the point that even Out magazine covered it. Giant squid is out. G in LGBTQ stands for giant squid. So this is what we're good at, exploration. And this is what we need to be doing. Because as Darwin said, it's not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is most adaptable to change. We need to be exploring our natural world and understanding it better so that we can create the toolbox that we're going to need to survive in this changing world. And to quote one of my other heroes, Jacques Cousteau, the future is in the hands of those who explore. Thank you.